Hello everyone, this is Professor Gant, and this is the final video in the series of homework lecture videos for Math 109, General Education Mathematics. The problems that we'll be doing in this video are listed. You'll see 35 through 37, 38, 39, 44, 40, 41, 45 through 47, and then we end with 49 and 50. And so again, I am doing these problems in the order in which I think they should be done according to the topics that they cover. Okay, your homework is kind of just put together where they just kind of throw a hodgepodge of stuff in there, but I'm trying to order these in a way to where all the topics kind of go together and make sense. So this is what we'll be covering. So we're going to start off with the topic of complementary and supplementary angles. And so questions number 35, 36, and 37 go through that. So I'm going to go ahead and erase these, and we'll talk a little bit about complementary and supplementary angles, and then we will calculate. So whenever we talk about an angle in general, we have angles that are what we consider to be in standard position. And what we mean by standard position is that the angle starts at the positive x-axis and it rotates in a counterclockwise direction, okay? And so let's say we name this angle theta. So when we have an angle that starts at the positive x-axis and rotates counterclockwise, we say that that angle is positive. If we start and we rotate it clockwise, it's going to be negative. So remember, angle counterclockwise rotates, it's positive. When it rotates clockwise, it's negative, okay? So when they say here the angle 41 degrees, they're talking about taking the angle and rotating counterclockwise, okay? Now, an angle has what we call an initial side, which is our positive x-axis here, and it has a negative side, I'm sorry, not negative side, but a terminal side, and that is what this is here. And so the angle is what is in between the initial side and the terminal side, okay? Now, whenever we talk about a complementary angle, or complementary angles, I should say, and I'm going to name this angle here alpha. Let's say we have one angle from here to here, another one from there to there. We know that angles are complementary whenever we add those two angles together and they end up equaling 90 degrees. Okay, so that's what a complementary angle is. The sum of those two angles is 90 degrees. When we have supplementary angles, we add the two angles together and they come out to be 180 degrees, okay? So here for this question, we say find the measure of the complement and the supplement of 41 degrees. So here, if we know that, let's say we let theta equal 41 degrees, then the complementary angle to 41 degrees is going to be alpha. And of course, for there, all we would do is just subtract 41 from both sides. And I'm going to rewrite that 41 degrees again to make it look a little better. So here, we would subtract 41 degrees from both sides. And this is just alpha. And of course here, this will end up being, let's say 9, and that would be 49 degrees here. So we know that the complementary angle to 41 degrees is 49 degrees, okay? So we'll go ahead and put that in. So you can probably figure out that the supplementary angle, if we allowed, let's say theta here to be 41 degrees. And 41 degrees plus alpha is 180. So literally all we have to do is just take 180 and subtract 41 from. Okay. Of course, if we do that, then of course we get 139 degrees. And that should be what this angle should be. So that's all there is to it as far as complementary and supplementary angles are concerned. So we go to question number 36. We're being asked the same thing. So again, for this situation, for the complementary angle, all we need to do is do 90 minus 33.8. And of course, if we do 90 minus 33.8, we get 56.2. And so I'm just going to write in the 56.2 degrees. And of course, for the supplementary angle, it's going to be 180 minus 33.8. And of course, when we do that, we end up getting 146.2. So I'll just erase this part and do that. So that's all there is to it. We'll move on to the next question. So for this one, it's a little different, but it still has something to do with complementary and supplementary angles. So for this figure here, we're asked to figure out what is going to be angle A, angle B, and angle C. Okay. Now, first thing that we want to realize here is that we have what's called alternate interior angles. Okay. And I'm going to erase here to kind of illustrate what that means. Okay. Now, in geometry, there is this basic rule or a basic theorem or principle that says the following. If I have two lines that are parallel to one another, so say I draw this line here, I draw that line here, and I have another line not parallel to both of these lines that crosses through it. They say it traverses the two lines, but that's just a fancy way of saying it crosses through it. Then whatever angle this is going from here to here, this angle here will be the exact same thing. And that's what we called alternate interior angles. So if I had this situation here, and let's say this angle was 30 degrees, then I know that this angle here, going from there to there, would be 30 degrees if this one is 30 degrees. Okay. Now, the other thing that we need to know is that if we have this situation here, same situation, that we know that this angle, we know that this angle here plus that angle here are supplementary. And we know that because the sum of alpha and beta together would be 180 degrees. And how do we know that? Well, we know that a circle has, from start to finish, if we go all the way around, has 360 degrees. And so halfway there is 180, which would be what we call a straight angle here. Okay. And of course, if we go from here all the way to there, that would be a straight angle, which is 180 degrees. So in knowing that, here we see that this angle here is 46, and we see that this is two lines where L and M are parallel to one another, and we see that we have this line traversing or crossing through it. If that's 46 degrees, then angle A is also 46 degrees because of what we know about alternate interior angles. Okay. So now that we know that, I'm going to kind of draw this figure here. So we got these two lines, got that line crossing through, that line crossing through. And we have another one kind of crossing through like this, where these are being intersected at 90-degree angles there. And we said that this angle was 46 degrees. So this one had to be 46 degrees as well. Okay. Now, we also need to figure out what is angle B and what is angle C. Now, here, this doesn't look too hot, but what I'm trying to show here is that this is a 90-degree angle here, okay? So B, angle B is just going to be whatever 46 plus 90 is, and we're going to take that away from 180. So we know that the total angle measure from here all the way to here is 180, but we're going to subtract 46 degrees and then subtract another 90, because if we had a right triangle here, we know that whenever we have the box there, that lets us know that that angle is 90 degrees. So we're going to subtract that. So if we take 180 degrees and subtract 46 and another 90 from it, what we end up with is 44 degrees. And so that is essentially what angle B is. Now, the last angle that we need to find out is what angle C is. And we actually have two ways of being able to find out what that angle is, okay? Now, the simplest way to do it is using this concept here. Notice that we said that whenever we started this, that this angle and this angle were the same. And of course, this angle theta and alpha were supplementary angles, okay? So you can see here, this angle and this angle are also supplementary to one another. So we know that angle C is just going to be the supplement of 44. Of course, if we do 180 minus 44, we get 136. And so that would be what this particular angle is. And that's probably the easiest way to get it. Another way that we could do it is, if you notice here, this is a right triangle. And if that's 46 degrees and that's 90, since a triangle has a total of 180 degrees, this angle here has to be complementary to 46 degrees. And so the complement of 46 degrees is 44. And of course, this angle and angle C are supplementary to one another. So if we have 180, we have 180 minus this angle here, which is 44 degrees, that would give us the 136. So that's another way we could have arrived at that answer as well. All right, let's move on to number 38. So for number 38, we need to talk about what we mean when we say similar figures or similar shapes and their relationships. So I'm going to erase what I have here. We'll talk about what we need to be able to understand this problem, and then afterwards we will figure out how to answer this. All right, so for problem number 38, we're given two figures, and we're told that these figures are similar. And of course, that's a key word that we need to talk about. And it says, given the lengths of the sides and measurements of the angles in the left figure, what do we know about the information on the right figure? Now, what we have to know about similar shapes, and I'm using triangles here because usually this type of thing is used with similar triangles when you first learn it, but it just goes for shapes in general. Whenever we have shapes that are considered to be similar, then what that means is that the sides of both of those shapes are proportional to one another. So here we're saying that side big A divided by little a is going to be proportional to side big B divided by little b, which is also proportional to side big C divided by little c. Okay, so all these sides are proportional to one another in this same way. We also know that the angles of the big figure or the bigger figure is going to be the same as the angles of the smaller figure. So in short, we say that for similar shapes, the angles are the same that's created by the sides, and the sides themselves are proportional to one another. Okay. So if we look at our figure here, what we do know based upon the information that's given, here we know that if this angle is 31 degrees, then this angle here is also 31 degrees. So that would be angle I. So in this case, out of all the angles, we definitely know information about angle I, and we know that it is 31 degrees. The next thing, we want to find out the length of a side. So here, what you notice is that we have the side 98, we have the side 84, okay? So here, we know that this side line segment AB and line segment FG, and I'm going to write it like that, line segment AB to line segment FG is proportional to line segment CD over line segment HI, okay? And here we know that AB and FG are 98 and 84 respectively. We also know that side CD is 56. And the side HI is what we don't know, so we'll just let that be X. So from here, if you want to make this simple, if you remember, this is a proportion. And if you watch the videos that I talked about, the very first one in this series with linear equations, then you'll know that I talked about proportions. And we said the quick way that we can do proportions is to cross multiply. So here we can do 98x is equal to 84 times 56. And then here we can just divide both sides by 98 and get what x is. So here our numerator, if we do that, of course, if we do 84 times 56, that would give us 4,704 divided by 98. And if we take that answer divided by 98, we get 48. So we know that this side here, HI, has to be 48. That would be 48 units. And so that's all we need to know about that particular problem. So let's move on to number 39 now. So for number 39, we see here that we're given some, we need to find this distance D. And of course, what this is saying is, hey, we need to find this distance across the river. And we assume that the triangles here for this situation are similar. So we know that this side here and this side are proportional to each other. So that means that this side and this side will also be proportional to one another. So erasing what we had here in the last problem and using what we know for this one, here I know that 125 is to 30. 125 is to 30 as D is to 180. And so here I know that again I can cross multiply. And if I do that, I'll have 125 times 180 equals 30 times D. And to get D by itself, we just divide 30 by both sides. And that just gives us D on the right. I know that 180 divided by 30 is just 6. So that gives me 6 here, 1 there. And if I do 125 times 6, that will give me 750. Okay. If you don't like it doing the way that I just did, then of course you can just say the 125 times 180 125 times 180, that is just 22,500. And if you divide that by 30, we still should get 750. So regardless of how you want to do it, it'll still end up being the same way. So right here, this will be 750. All right, we're going to skip a few questions now and move on to example number 44. And as you can see, this is an interesting type of problem, but the concept is pretty much the same. So I'm going to erase what I have down here to give myself a little room, and then we'll go ahead and work out this problem. All right, so for this problem, it says Jane wants to place a surveillance camera at location C right here to observe the Smiths at location X over here. The camera cannot be seen directly from position X here because of a large clump of bushes that are right here. The camera will take pictures by aiming at a building, which is right here, with the shiny mirror-like sides. So in other words, they're going to get a reflection of whatever they see over here and just take pictures there, okay, as shown in the diagram. How far should the camera be positioned from point I? In other words, how far should it be from here? So what is this particular distance here for this setup to work? Okay. Now, a lot of words, but really boils down to is we have one shape here, which is a triangle, and we have these two sides, and we also have another triangle over here that's small. And so we know that if this angle and this angle are the same, and they're both right triangles, then here, this particular triangle has to be similar to this one, okay? So here we can do just like how we did in the last problem. If we want to find out this distance here, then we just say the length of line segment CI is to 400 as 300 is to 1,000. And of course, this length here, I'm going to replace that and just call it D, just because we want to know what that distance is. So I think having a D there would be easier. So I'm just going to go ahead and erase that and say that that's distance D. And so here, all I need to do is figure out what D is. And of course, to do that, I can just multiply both sides of my equation by 400. Or another way, which you're probably used to doing by now, is we can do cross multiplication, same thing. So if we do cross multiplication, then we have 1,000 times D is equal to 400 times 300. Of course, 1,000 D over here, and 400 times 300 is 12 with 4 zeros. And we just divide both sides by 1,000. And on this side, that just gives us D. And over here, this should give us 120. And that should be what, how far it should be from point I, 120 feet for this setup to work. All right, so now what we'll do is go back to question number 40, and we're going to talk about polygons now. And so what a polygon is just a shape, okay, with several sides. For instance, a triangle is a polygon that has 3 sides. A square is a polygon that has 4 sides, and all the sides are the same. A rectangle is a polygon with 4 sides, and 2 of the sides are not the same as the other 2 sides. Okay, so when we say polygon, it's kind of like a catch-all phrase to mean, you know, any closed shape that has number of sides. All right, so next we'll do problem number 40, and it says, what is the measure of an interior angle of a regular polygon with 6 sides? Okay, so just so that you know, a polygon with 6 sides is called a hexagon. And so we're just looking at basically a hexagon, and we're trying to figure out how many sides, what's going to be the interior angles for. Okay. Now, we can normally figure this out by the formula that I have here, which is n minus 2 times 180 degrees divided by n, where n is equal to the number of sides of the polygon. Okay. Now, just in case you're wondering what a 6-sided figure looks like here, I'm going to draw it. So that is what a hexagon looks like. Okay. And so what we're trying to figure out here is, if we were looking at this, what is this angle right there? Because all the angles around here would be the same. So all we have to do here is plug in. So we'll just say interior angle is equal to 6 minus 2 times 180 divided by 6. And of course, we know that 6 minus 2 is 4. And here we can do 180 divided by 6 is 30. And 4 times 30 is 120 degrees. So that should be what our answer is. All right, so we'll go ahead and do the next question as well. So our next question says, if each interior angle has a regular polygon each interior angle of a regular polygon measures 150 degrees, then how many sides does that polygon have? So in the question that we had before, what we did is we were given n, we figured out the angle. Now what we're doing is we know the angle, we need to figure out what n is, okay? So here I'm going to erase, and we will work this out. So in this case, I'm just going to write here angle is equal to n minus 2 times 180 all over n. And so now we need to figure out what n is, given that this is 150. Okay. Now, one way that we could start off by doing this is realize that 150 is the same as 150 divided by 1. And if we have that scenario, then you see what we have as a proportion, and we can cross multiply. When we cross multiply, we have 150 times n, which is 150n. And here we will have 1 times all this, which will be just itself. Okay. Now, we need to get n by itself. So here, what we need to do to be able to eventually separate n by itself is we want to distribute 180 to both terms here. And so this will give us 180n minus 360. And then here, we just need to get n by itself. So both of these terms have n's. So we want to get them on the same side. So what I'm going to do here is subtract 180n from both sides. And if we do that, that cancels to be 0. And we just have a negative 360 here. And if we take 150n minus 180n, that gives us a net negative 30n. And then to solve for n, we just divide by negative 30. And so here, we know here that negative 30 divided by negative 30 is 1. 1 times n is n. And here, if we take negative 360 and divide it by 30, we will end up getting a positive 12 because we know negative divided by a negative is a positive. And so for this one, this will have to have 12 sides. All right, so the next set of problems that we'll do will address area. And so we'll talk about area of a rectangle, area of a triangle. All right, so for our next three questions, we'll be talking about area of a triangle. And so, area of a triangle, rectangle, or circle. And for the first one, we're just asked to figure out what is the area of the rectangle. And of course, if we can see from here, the area of a rectangle is just length times width. So all we need to do is to multiply 83 times 28. Of course, if we multiply 83 times 28, we get 2,324. Where that is we'll call that the length, and we'll call that the width. And of course, the units are in square feet, because it's just feet times feet, which is feet squared. For number 46, we're asked to find what is the area of this triangle. And of course, with triangles, we need to know what the base and what the height of the triangle is. So the base is here, the height is there. And we show that the base of this triangle is 9 inches, the height is 5. So in this instance, area of our triangle is just 1/2 times the base, which is 9, times the height, which is 5. And that ends up being 45 divided by 2, because 9 times 5 is 45. And of course, if we do half of 45, that's just going to be 22.5. And of course here, 22.5. And again, we're in inches here. So here, if you have inch times inch, then the resulting units will be inch squared. So here when we choose this, this will be inch squared, or sometimes we call it square inches. All right. And so for number 47, very similar. Here we see that the height of this triangle here is going to be 12 centimeters, even though it's kind of drawn like an oblique triangle. An oblique triangle is just one that doesn't have any right angles. So this actual shape here that's in the bold is an oblique triangle. But we know that the height of it is from the base up to the very top. And so that 12 centimeters here represents the height. The base of the triangle is going to be 21. So area of triangle, here, all we have to do is just replace the numbers here. So we'll just get rid of all of that. It'll just be 1/2 times the base, which is going to be 21, times the height, which is 12. And of course, here if we do, if I want to simplify this, make it real simple, 12 divided by 2 is 6. But for those of you who may not like me doing it that way, I'll just go ahead and multiply 21 times 12, which is 252, and divide that by 2. And of course, half of 252 is 126. And in this case, this will be square centimeters. So get rid of that. Because this was in centimeters and the 12 was in centimeters as well. All right. And so for our last two problems, 49 and 50, we will talk about the Pythagorean theorem. So for question number 49, we're told that we have a baseball diamond, and it is in the shape of a square. So we know that all the sides of that baseball diamond are the same. And of course that measure is 78 feet. And we want to determine the distance from home plate to second base. So in other words, we want to determine this distance from here to here. Now, to be able to figure out this distance here, one of the things that we can use is Pythagorean's theorem. And we know that because Pythagorean's theorem tells us the relationships of all sides of a right triangle, meaning a triangle that has a 90-degree angle. And of course here we can see the distance from home plate to second base, and of course two of the sides of the diamond together form a right triangle. So we can use Pythagorean's theorem to figure out what this particular answer is. Okay. Now we know the Pythagorean's theorem says that the two legs, which are the shorter sides of the right triangle, if we square each of those sides and add them together, it should be the same as the square of the longest side of the right triangle, and we call that the hypotenuse. And in this case, the distance from home base to second base is going to be the hypotenuse. Okay. So here what we have, if we kind of redraw this, is this situation here where we have 78, 78, and we're trying to figure out what this side is here. Now, being that we know this relationship, there are some basic right triangles that we should know, and I've written them in variable form so that we can use it for this problem here. And we know that if the two legs of the right triangle are the same, we call that an isosceles right triangle. Okay, and that's how you spell it. But basically, all that means is that for the right triangle, two of the sides are the same. And so when we have that situation here, oops, and I forgot to write this. This should be an A right there. Then if this is A and that's A, then this is going to be square root of 2 times A. And the reason for that is because of how Pythagorean's theorem works out. So here, if I use Pythagorean's theorem on this, I would have A squared plus A squared equals to, let's just say, C squared. And if we're trying to solve for C, we know that A squared plus A squared is 2A squared here. And if we want to solve for C, we have to take the principal root of both sides, which is plus or minus square root of 2A squared. And here, we would get rid of the negative part because this C represents a distance, and distance can't be negative. And here we would have this as square root of 2 times square root of A squared. And square root of A squared, for all practical purposes here, is just going to be equal to A. Okay, and we're saying that because A itself is going to be some non-negative number. Okay, so try to keep this simple here. In actuality, square root of A squared actually equals what we call absolute value of A. But since A is, in this case, going to be assumed to be something that is greater than 0, we can just simplify that to A. So that's why I just wrote that there. But my point is, do you see how the hypotenuse is the same as square root of 2 times whatever that side is? So in knowing that, if we want to know what this side here is, I don't have to go through all this for the Pythagorean theorem. I already know that this side here should just be 78 times square root of 2. Whatever that side is, times square root of 2. And so all we need to do now is just figure out what 78 times square root of 2 is and round that to the nearest hundredth. So we'll go ahead and bring in our graphing calculator here. Let me grab it right quick. And we'll type in 78 times, and our square root button is this blue square root sign right above this button. So we'll do blue, that, 2, move the arrow out, and then we see once we enter, it's just a little over 110. Now, if you don't have this button here, then one thing that you could do is this. Square root of 2 is the same as 2 raised to the 1/2. So you could write this as 2 and then raised to 0.5. Get that answer, and then multiply that times 78, and you'll see that you get the same thing. So here, we're told that this 78 times square root of 2 is roughly equal to 110.3086,579. And I'm doing approximate because square root of 2 is an irrational number. So no matter how many decimal places we write this number out to be, it will never be the exact value. And we're asked to round to the nearest hundredth, which is to 2 decimal places. So this is the second decimal place. We look at the third, and since this is 5 or higher, then this needs to move up to a 1. So here this would be 110.31 feet. All right. And so now for our final question, we're asked to find out what the length of AB is based upon the information that we have here. I'll move to a next page to do that. So for this problem, what we need to do is start with the triangle, the right triangle is to the furthest right, and just work our way to figure out this one. So here I have 1 meter, 1 meter, and I got to figure out this side here. Now, if you remember what we talked about, we said that if we have a right triangle and both sides, both legs are A, then this is just A times square root of 2. So this means this should be 1 times square root of 2, which is just square root of 2. Okay? So this side right here is just square root of 2. Now we're going to focus on the right triangle that's made up of having square root of 2 as one of the legs and 1 here. We got to figure out what this side is. Okay? And I'm just going to call this particular value here C1. Okay? So using Pythagoras theorem, I know that this side squared plus that side squared is going to equal to this side squared. So I have square root of 2 squared plus 1 squared equals C squared. And square root of 2 squared is just square root of 2 times itself, which is square root of 4. And square root of 4 is just 2. So anytime we take the square root of something and square it, it just ends up being what's under the radical there. And of course, 1 squared is just 1. And 2 plus 1 is 3. And so using the principal root that we learned, we know that C is equal to plus or minus square root of 3. But we know that since C is a distance, distance can't be negative. We have to ignore the negative on that. And now we know that C is just equal to square root of 3. So this length right here is square root of 3. Now, finally, we look at the right triangle that has one side square root of 3 and 1. And we need to figure out what C2 is. And we just do the same thing over again. So here we know square root of 3 squared plus 1 squared is equal to C2 squared. Okay? And yeah, I forgot to label this. This should have been C sub 1 for all these. Sorry about that. So here we know that square root of 3 squared is just going to be what? That's right. It should just be 3. Plus 1 squared is just 1. And this is just C sub 2 squared. And we know that square root of, 3 plus 1 is 4. And from here, if we do the principal root, this will be plus or minus square root of 4, which would just be c sub 2. And of course, square root of 4 is just 2. And since we have to ignore the negative, we only use the positive value of 2. And so with that, that concludes most of what we talk about in Module 4 as far as the homework problems are concerned. Again, I hope that these videos were helpful in getting you through this particular assignment, and at the same time having you learn some of the basic concepts that you need to know to be able to get through the assignment. Let me know if you have any suggestions or other feedback on how to make this better or a little bit more understandable to you. If you like it, then let me know that as well. Again, thank you so much for tuning in, paying attention. Take care.